Let's start. Bismillah wa salatu wa salam ala Rasulillah. Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, everyone. Today, our session number 9, we will speak today about the reciprocating compressor. Today is main topic about the compressor. And actually, as we studied in the oil and gas industry, the compressor is very important in all sectors. As we know, the whole stages for the oil and gas started from the upstream refinery, which is downstream, and between them is the midstream. In each area, the compressor is required. If you want to do liquefaction, you need to do liquid gas, you need to do LNG, liquefied natural gas. If you want to compress air, if you want to compress nitrogen in the downstream, you need to have a compressor. So the topic today is about the compressor in general. In specific, we'll speak about the reciprocating compressor. Reciprocating compressor. So our agenda today will speak about the definition and types of compressor in general, and what is the compressor, what is the meaning of compressor, why we need a compressor, what is the usage of compressor, why we use a compressor, what is the importance of compressor. After we finish this one, we'll second speak about the minimum or general notes about reciprocating compressor. So we will go specifically about one type to describe and to explain, which is reciprocating compressor. We have two major types of compressor. This will explain. Today, one major topic or one major type of compressor is reciprocating compressor, which will be our session today. We'll speak about the arrangement of the reciprocating compressor, how we arrange the reciprocating compressor, how we locate the reciprocating compressor, what is the equipment related to the reciprocating compressor, how we put this equipment, what is before, what is after. This is we'll study. Then we will study also the piping surrounding or surrounding the reciprocating compressor. So let's start with the compressor itself. What is compressor? What is meant by compressor? It is from the meaning compress. Compress is to compress. Compress what? Is to compress the gas or vapor or air. Any kind of gas or vapor or air, this is a machine that is required to increase the pressure of the gas or vapor or air by compressing. How we are compressing the gas or air or the nitrogen, for instance? By reducing its volume. If someone of you, he understands mechanical engineering, he will understand what I mean. This is a relationship between the volume and the pressure. P is for pressure. V is for volume. Volume, this is a volume, right? Like the room that I am now staying in a volume. This is a room that is I am inside, so I am inside the volume. This is the volume. This, for example, cup of tea or instant. This is volume, contain volume of liquid. So this is the volume. What is the pressure? Pressure is the force on area or the force relative to area, which I need a pressure to transfer flow from point A to point 2 or to point B or point 1 to point 2. This is the pressure. So the pressure is the required force to transfer the flow from point 1 to point 2. So what is the gain here? Okay, what I need to say that the compressor is a machine that is increasing the pressure. How it works is by reducing the volume. So the pressure here, for instance, is very, very low because I am here. If I am increasing the pressure, here, if I am moving in this axial x or the vertical x, that means that I am going up to the pressure. I am increasing the pressure. The increasing in the pressure will not happen without reducing the volume. Reducing the volume. So V in the vertical x is for volume. So I am reducing the volume here. I am going now to increase the pressure by reducing the volume. This is more engineering, I know that. Let's go to the practical. Yeah, here is the practical. Now, this is a cylinder. This is a reciprocating compressor as an example. This is the size, this is the volume here. This is the volume. Here is the volume. If I decrease the volume by moving this piston towards the left, meaning that I am decreasing the volume. If that happens, then the pressure will increase. Pressure will increase, that will give me the force that I need. That's it. I need force. The force will allow me to move. I need to move. So the flow now is ready to move from point 1 to point 2. This is all. So this is exactly the compressor, how it works. So the compressor is a machine that works to increase the pressure of the flow. Why we need to increase the pressure? To transfer it. That's it. I need to transfer natural gas. This is gas, right? How I can transfer it? I need to use a compressor. All right. So to use a compressor, I need to have a machine that is allowing me to decrease the volume of the flow. By decreasing the volume, the pressure will increase. This is an equation. If you know the compressor that is used for the car wheel, if you have a car wheel and the car wheel is needed to increase some air, right? So you go to the workshop or on the road while you are traveling, driving your car, you are stopping by a workshop that has a compressor, that have a machine. All of you use the compressor. Yes, you use it. Use it in your car or even your bicycle. Yes, you have bicycle when you are a child, or for your kids, for your daughter, for your son, you purchase a bicycle. Then what happened to increase the pressure inside the wheel of the bicycle? What you will do? Yes, you are using compressor. Correct? You are using compressor. You are using a machine which allow you to give air. How they are forcing air? How? They are decreasing the pressure and decreasing the volume and increasing the pressure. That's how the flow will transfer. Flow will transfer by this mechanism. So why we use a compressor in oil and gas industry? Because I said oil and gas. I didn't say oil only. I said gas. If I say oil only, I don't need compressor. It is oil, it is liquid, so I need only pump. Correct? Which we studied last lecture. Last session we studied the pump. This is only required for oil. But what happens if I need gas? I need to transfer gas. I need to transfer air. I need to transfer nitrogen. I need to transfer water. What happened to the gas? How I transfer it? Natural gas, liquefied petroleum gas, this all gases, how I transfer it? By compressor, by using the compressor. So that comes to our mind that the compressor only uses for gases and vapor. That means we cannot use the compressor to compress liquid. This is not allowed. It will damage the compressor. Vice versa, like we have studied in the pump only used to compress or transfer or to pump liquid. It cannot pump vapor or gases. If you need to pump gases or vapor, then use compressor. And also, you cannot use compressor for liquid. Is it clear? All right. So, as I told you, the gases are compressible. What's mean by compressible? Gases are compressible means that it can be compressed. If you have a volume of air, if you have a room like this room that I am staying now, and you have a liquefied petroleum bottle gases or compressed air in a bottle, and you open it. You open it, right? These gases will quickly go over anywhere, all the way. They will actually occupy all the space, all the volume. The new volume will be occupied by the gases which was compressed. It will be occupied in a new volume to accommodate all this room. Vice versa, if I need to suck all the gases and liquid from the room, I can compress all of them in a bottle or in a, for example, a cylinder. This can be compressed. So the gases can be compressed because they always have the molecular weight for gases. They always have a distance between each other. They are separated, so they can be compressed. Always I can compress gases. I always can compress gas. However, the liquid, they are not able to be compressed. They are incompressible. The liquid is opposite to gases. The liquid is incompressible. So the gases are compressible. However, the liquid is incompressible. Is it okay? That's why, if you remember the session of liquefied natural gas, and if you remember why we need to transfer the phase of the gas from vapor to liquid to what? To be LNG, liquefied natural gas. Why? Why we do so? Yes, for that reason, because the liquid is incompressible and gases is compressible. So if the gases is compressible, so to transfer and store gases, it is better to change the phase of these gases to liquid. So I can have a lot of amount, but only compress it. Compressing the gases will not give me the required amount. I need more and more. Then transfer it to liquid. By transferring the gas to liquid, you ensure there is no space between the nuclears. All the nuclears are connecting to each other because they are liquid. They don't have space. They are occupying every point, every space they are in the cylinder, in the tank. But they have spaces, so you want to utilize the space. It is a cost, it is a money. You want to utilize the space. So how you are utilizing the space? Compressing is not only enough. You need to transfer it to liquid. Then you have the most volume available to transfer or to store in the market. Okay. So what is the type and definitions? Okay. What is the common type of the gas compression? As I told you, this is equally close the same to the pump. Compressor types is the same nearly to the pump types. We have a positive displacement and we have a dynamic, the same as a pump. The compressor positive displacement can be reciprocating or rotary. And the reciprocating compressor, it can be either single acting, double acting, or diaphragm. The rotary can be many types, like the pump, the same loop, screw, vent, scroll, liquid ring. These all reciprocating, which are by yellow colors. This all called, positive displacement, which is main rotary and reciprocating. However, the other type, which is in this blue color, okay, or sky color, this is not really blue, this is sky color, the dynamic compressor, which can be centrifugal compressor or axial type. The most common compressor types that we need to know, we need to learn is the centrifugal compressors and reciprocating compressor. So those are the most common types that are used in the gas industry. I didn't want to say oil and gas because we cannot use compressor in oil. We use it only in gas. But as an industry, we can call it oil and gas industry, no problem. Or petroleum industry. You can use reciprocating is a common use in the oil and gas industry or petroleum industry. You can use also centrifugal type. This is also common use. So this is dynamic type. This is positive displacement type. Let's focus now about the positive displacement type, which is the reciprocating compressor. The reciprocating compressor, it is the same machine that is being used in the internal combustion engine. It is close to that one. The internal combustion engine in your vehicle, in your car, they are using reciprocating type, piston and cylinder. And like if you know this car is 6-cylinder, 4-cylinder, 3-cylinder, 12-cylinder, you know that the type of cars is based on the number of cylinders. What's this cylinder? This is cylinder of the reciprocating one. If the cylinder that is acting with the piston to do the reciprocating cycle to compress the flow. So that's why we are using this terminology in the cars. This car is 6-cylinder or 4-cylinder. It means how many volume we have. That's why it's unit in cc. You are saying this car is 1,600 cc. What cc means? Cc is cubic centimeter. So that's mean volume. We are measuring the volume by Q. Volume, right? Because it has 3 dimensions, X, Y, and Z, right? The volume always has 3 dimensions. That's why we are saying cc, which means centimeter cube. So that's why we use this terminology in the car, because the car is using this reciprocating type compressor. So we have either 6-cylinder type in the reciprocating compressor, and this is mainly used for the high pressure and low volume flow rate. So if you need to just have a flow rate which is minimum low flow, but high pressure, high force, but the flow that you need is really low. You don't need much, you need a low. So that means you need a 6-cylinder type. Another type which is called a single-stage centrifugal compressor. This is a centrifugal type. It is close to the centrifugal pump. If you remember the last session, we studied the centrifugal pump. This is the centrifugal compressor now. It is close to the centrifugal pump. You can see this is closed to pump. We have here a motor, we have a shaft, and we have here inside this one, this is the rotary part of the compressor. It's called single-stage centrifugal compressor. It's driven by electrical motor. And the gas is entered from this side. So the gas is entered from this side, and this gas is not compressed yet. Then when it enters to this side, it will be ready to be compressed inside the volume of this one. So inside the compressor, there is like a rotary gearbox. They are actually compressing the gases, compressing it, then it will be exit or discharge from this area as a compressed gas. Compressed gas will be discharged from this gate. Okay, this is another type of compressor. It's called multi-stage diaphragm reciprocating compressor. So this is reciprocating compressor, but diaphragm type, and this is multi-stage. It is huge one. It also can be used in the oil and gas industry. This is centrifugal rotative compressor. This is also centrifugal. If you see this kind of rotary, this is dynamic. Dynamic means that I am changing the kinetic energy to the pressure energy or hydraulic energy. So this is a dynamic, which why is called dynamic. And this is also, as we studied in the pump, we also can see this one in the compressor, dynamic type, centrifugal type. This used in the low pressure but high volume. If you need high volume, then you can use this type. So the reciprocating type is the opposite, is used in the low flow but high pressure. This centrifugal pump is used in low pressure but high volume or high flow rate. Okay. This is one type of air compressor. This is another type of refrigerator compressor. It has definitely, it should be driven either by motor or steam. Here it's driven by motor, electrically means, and this is a compressor here. This is another type of refrigerator compressor. This is the compressor side. This is a suction and discharge. You have two nozzles here for suction and discharge, and this is the driver here. The driver is motor. Driver means how is this operate? How mechanical parts operate is driven by motor. So it can be driven by another way, like steam turbine. Axial flow type, this is part of the dynamic, but here it is axial type compressor. This is rotary screw compressor. This is positive displacement. It is not reciprocating. However, it is rotary. It is part of positive displacement type. Okay. So before we go further on the compressor, let's see one video that give you an example or a meaning of reciprocating compressor and how actually it works in the machine.
A reciprocating compressor compresses refrigerant vapor in a cylinder using a piston. In a way, reciprocating compressors are like automobile engines. The pistons are directly driven through a wrist pin and connecting rod from a crankshaft. Depending on their size, reciprocating compressors may have one or more cylinders. Multiple cylinders may be arranged in line, opposed, or in a V. In each cylinder, reciprocating compressors have both a suction valve and a discharge valve. These valves give the compressor its ability to pump refrigerant vapor against a pressure difference. They are usually located in the head of the cylinder, in passages connected to the high or low pressure side of the system. Let's follow the compression process in a single-cylinder reciprocating compressor during one complete revolution of the crankshaft. Starting with the piston at the top of its stroke, or at top dead center, the piston begins to move downward as the crankshaft rotates. Because both valves are closed, the downward moving piston reduces the pressure in the cylinder. As the pressure in the cylinder falls below the low side pressure in the suction line, the pressure difference opens the suction valve, letting refrigerant vapor flow into the cylinder. The piston continues down and pulls in more vapor until the cylinder is filled with low-pressure vapor at the bottom of its stroke. Once past bottom dead center, the piston begins its upward stroke. The suction valve closes. As the piston moves up, it reduces the volume of the space in the cylinder, increasing the pressure of the vapor. When the pressure in the cylinder exceeds the high side pressure in the discharge line, the pressure difference pushes the discharge valve open, letting the compressed vapor flow out of the cylinder. This continues until the piston reaches the top of its stroke and most of the compressed vapor has been expelled into the discharge line. When the piston begins its downward stroke, the discharge valve closes. The complete cycle then repeats during each revolution of the crankshaft. This is the mechanical positive displacement vapor compression cycle using a reciprocating compressor. Please take a moment to complete the following learning activity.
Okay. So this is how it works, reciprocating compressor. This is exactly the same that we are seeing in what? We are seeing in our car, in the vehicles cars. So how, if you need to know about the rotary type or centrifugal compressor type, how it works? Let's speak about centrifugal type.
For over 50 years, F.S. Elliott's oil-free centrifugal air and gas compressors have led the industry with a technologically advanced design that delivers reliable, trouble-free operation with the lowest cost of ownership, offering a horsepower range of 250 to 5,000 with up to 4 stages of compression. Our compressors are ideally suited to a broad range of industries. Every aspect of your compressor's performance is governed by our multifaceted Regulus control system. This easy-to-use central control system features the most powerful processors in the industry and can be used either remotely or at the site of the unit itself. With the unprecedented control provided by the Regulus system, a manager can operate one or more compressors at a time while simultaneously achieving the greatest energy-saving efficiency possible. Before entering the first compression stage in a multi-stage configuration, ambient air or gas must pass through F.S. Elliott's high-efficiency filtration system. From there, an inlet guide vane automatically adjusts itself to changes in system demand, regulating the incoming low-velocity air or gas stream as it flows toward the first stage impeller with a pre-swirl effect. As the low-velocity air or gas stream flows into the first stage stainless steel impeller at the inducer, centrifugal force directs its flow to the trailing edge. From there, the accelerated air or gas stream flows from the first stage impeller to a radial diffuser, which converts the air's high velocity into static pressure before the heated air enters the scroll casing. To ensure perfect aerodynamics, F.S. Elliott will custom design both the backward-leaning impeller and radial diffuser for your specific application. With each stage of compression, the air or gas temperature rises, pressure increases, and volume decreases. In addition to the impellers and radial diffusers, the rotor assembly consists of a pinion supported by 2 self-centering tilting or flexure pad journal bearings. Shaft seals on the impellers prevent gearbox oil from contaminating the compression chamber. Powered by a high-speed motor, the pinions and central bowl gear are machined to AGMA Quality Class 13. After passing into the scroll casing, the heated air or gas flows through the inner stage piping into the first stage intercooler, causing the moisture to condensate and separate from the lower velocity cooled air. Because F.S. Elliott intercoolers feature straight-through tubes, cleaning is possible, rather than costly replacement. As the air travels through the corrosion-resistant plenum, the separated condensate is removed from the compressor through a drain valve located at the bottom of the intercooler enclosure. By regulating the discharge of condensate, the drain valve increases the efficiency of the process by preventing unnecessary compressed air loss. Once the condensate is removed, the cooled air exits the intercooler and flows into the inlet duct for the next stage of compression, during which the entire process is repeated. The compressed air or gas then moves to the aftercooler, where it's cooled and any remaining moisture is removed. This highly energy-efficient process concludes with the delivery of ISO 8573-1 Class 0 certified oil-free air, ready to power a variety of industrial applications. Depending on the number of stages within the configuration, discharge pressure can reach a maximum of 350 psig or 23 bar-g. Whether your application calls for a hard-working industrial compressor package or an engineered custom design, you can count on FS Elliott to deliver efficient.
All right. So this is just a quick information videos about the two types of compressor, major types, which is reciprocating compressor and the centrifugal type compressor. Let's speak about now more details about reciprocating compressor. This is the reciprocating compressor. This is how it works. This is, if you can see here in the photo, this is a cylinder that has a crankshaft connected to each other, and this is connected to the shaft, which is axial, is rotating the crank, and the crank is vertical, and which is moving vertical, it moves the piston, and the piston will try now to compress the flow, and moving in the other stroke, it will try to suck the flow. So by sucking and compression, this is all our process. That's why they call it reciprocating type. Is going back and forth, 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 like this, quickly. And this is the same as we use in our car. And this is called the how many revolutions you are seeing. This is RPM. This is the RPM that you are looking in your car monitor to see what's the speed that you are moving. This speed RPM is the moving of the engine. The engine, not the speed of the car. So this is the engine. How many revolutions per minute these crankshafts are doing every minute? It is 1,000 or 2,000 or 3,000 revolutions per minute. 3,000 RPM. This RPM, this is the screen that you are seeing in the car when you are moving on the road. So this is the RPM, revolution per minute. This is numbers. Is transferred to the number of strokes that is required to compress, suck and compress, suck and compress, suck and compress, suck and compress. This is movement. Now you are using energy by this one. So this is how the reciprocating compressor works. This is a typical example of the internal combustion engine. All right. And this type they are saying here is have very high maintenance cost and lower capacity than the dynamic compressor. So the reciprocating compressor in the industry, in the oil and gas industry, because it is huge, it requires high maintenance. It requires more repair, require more changing in materials, and lower capacity than the dynamic type like centrifugal compressor. And the compression cycle is composed of three cycles, which is our intake, compression, and discharge. Intake, compression, and discharge. Intake to intake the flow, sucking the flow, compression to compress the flow, to reach to the required volume, deadline volume that is mainly required now to discharge, then discharge the valve will open for discharge. All right. So this is more type of reciprocating compressor. As you can see, this is small type of reciprocating compressor. It is like maximum 30 horsepower as a power. This is mainly used in automotive application, as I told you, in the workshop that you want to increase the air in your car. This is we use daily, this kind of compressor. This is maximum, this is small type, which is maximum 30 horsepower. And we use some large reciprocating compressors that can be reached up to 1,000 horsepower. This is mainly used in the industrial practice like oil and gas industry. And it will be more type, more in size mainly. So the discharge pressure can range from low pressure to very high pressure. It can reach up to 35 megapascal or more than 5,000 psi. So this is how you can see how many stages here in compressor to reach to this kind of pressure, very high pressure. So this is called multi-stage pressure, multi-stage reciprocating compressor. So in the multi-stage reciprocating compressor, the gas is compressed to an intermediate pressure first. Then the other cylinder is to raise the pressure from the intermediate pressure to the end pressure until to reach to the destination. We have some arrangement of the compressor. How we arrange the reciprocating compressor? Okay. So first of all, the reciprocating compressor requires a structure like this one. Why? Because as we told, the reciprocating compressor always frequently require maintenance. Maintenance is required frequently. So you want to have this kind of hookup. This hookup is required to carry on the heavy part on the compressor, like driver, like the shaft, like any kind of heavy part you want to carry, so that they will be allowed to have this enough weight. So you are using this hookup in the craneway beam, and this is actually monorail, and this is actually cannot be done without structure. So that's why we are using this huge structure always as a house shield for the compressor. So if you look to this one, you can see first the compressor. This is a compressor. Second, here you will see the driver. Here is a driver, which can be motor driver or steam driver, any kind of driver, but you have to have something that drives the compressor, like the same as your car. The car, you start with the battery. You start the engine with your key to start the battery first. So starting the engine without driver, which is battery, electrical source, you cannot start the engine. So the engine first needs a power to drive, to be driven. So this is called the driver. Third, you have a suction pulsation dampener. This is dampener. This is actually to damp the vibration and noise at the suction or intake nozzle. The compressor, as we told, the reciprocating compressor, it is have very kind of movement, can reach to 3,000 revolution per minute. So the compressor with pump, suction and discharge, sorry, with the piston and the cylinder intake and the compression and discharge, it has a revolution and strokes very frequent, and this is actually cause noise and vibration. So you need to dampen this one. How are you damping this one? By using suction pulsation dampener. This is required to balance, for balancing, to absorb the vibration, to absorb it. We have also discharge. If you have in the suction nozzle, you will also need and discharge the same. Discharge pulsation dampener to absorb the vibration, to absorb the noise, to absorb any kind of movement, to make the whole structure balanced without more vibration. You have a crank with door area, and this area should be kept free. Should be kept free. This is nothing here, but this should be kept free for maintenance purpose only, because the crank is here and you want to move the part for maintenance only. So you want to leave it area here on front of the crankshaft free to be accessible for maintenance. You have a control panel, and this control panel is used to control the machine. To on or off the machine, you have a control panel here, and this is connecting to the control room. But the operator, he can use the control panel to control the machine, or the machine using the control panel, either on or off or whatever. Craneway beam, this is a craneway beam that as I told, it will carry the hook for maintenance purpose. This is operating platform, and this is platform, it will carry the everything. The operation will be in this area. It is a platform, and the compressor will be on it. You have a sleepers to carry on the pipes that will be going through the area for suction and discharge nozzles. You have a pipe to connect to the equipment. So you need to use a sleeper to carry on this kind of pipe. Sleeper is something like a structure or like a beam that is used to carry on the pipe. It's like pipeway. You have a knockout drum. This knockout drum is very important. It's like a vertical vessel. This is important. Why? Because it will ensure that the flow that's going only to the compressor is gases only. There is no liquid. So the knockout drum is only an insurance equipment or something like before the machine that we ensure that we are only providing gases and vapor to the compressor. There is no condensate, there is no liquid, there is no kind of droplets, because if any kind of droplets or condensate inside the compressor, it will damage the compressor. So that's why we need the knockout drum. And we need the compressor foundation. This also required. And we need this chain axis for maintenance, as I told you. So this is the main equipment of the compressor, which we normally use in the industry. So this type of compressors, as I told, is required mainly axis. So you have to provide axis. If we are looking here, plan view, this is plan view. So I'm looking from the top as you are in the airplane and you're looking down. So this is looking from top, and you will find here is a compressor, and this is the platform, and this is the equipment knockout drum are here. And this is all the structure. This is the pipeway, and this is pipeway. This is another compressor also here. So this is brown area is free for access, for maintenance. So the trucks can easily come here in this area for maintenance purpose to carry on the material or the part that's required to be repaired or required to be replaced, so that it can be easily carried on. Without this free area, we cannot carry any heavy part of the machine. It is really heavy. So we need a free access area so that the trucks can go over here and they carry, maybe they can carry the motor, they can carry the shaft, they can, have enough space to move on and to do the maintenance requirement. So as I told you, these compressors should be out of any noise. So when it is located inside the administration building, so the people that they are working, the operators, they should use something to protect their ears. So this is ear protector to protect their ears from the heavy noise and heavy vibration. So always the knockout drum is required to be close to the compressor to ensure that there is no liquid enter to the compressor, it's only gases. Okay, another here area, this is for the pipeway, mainly for the piping that is connecting to the compressor. We require to give them some access way or platform, because maybe have some valve, one and all valves should be accessible from platform. So we provide platform as well to access the on and off valves around the pipeway. This is also another arrangement for the compressor. You need also to give a craneway access. As you see here, you should have enough space for drop area. If you are moving a part and you need to drop this part for maintenance, you have a drop area here. It will be enough space for the machine or the part or the things that you want to drop it for maintenance purpose. And the truck access, they can have here access for truck to go over the area for maintenance. All right. So this is a type for four-cylinder reciprocating compressor with gearbox, and this is two-cylinder type reciprocating compressor. So if you increase the number of cylinders, definitely you are increasing the pressure. If you're increasing the cylinder, that means you are increasing the pressure. As we are speaking, the cylinders type means that you are increasing the flow and you're increasing the pressure. We have to ensure adequate area for piston removal. The pulsation damper here should be located parallel to the compressor as close as possible. So the lube oil also, there is a lube oil console for lubrication part. This is also required as part of the compressor. So this is all our areas that should be considered within the compressors, that we should ensure adequate area for the piston removal. The pulsation damper should be located parallel to the compressor as close as possible to consider also the maintenance requirement. This is single cylinder reciprocating compressor, belt driver, and this is V-type reciprocating compressor. So this is V-type, and this is single cylinder belt driven. So this is V-type is reciprocating compressor, but it has arrangement like V-type, like this one. This is one piston and cylinder here, and there is one piston and cylinder here. They are putting like this arrangement. It is called V-type because it is have like V shape. This one. This one compression cylinder here, and this is one compression cylinder here. Both are connecting here in this point, so that's why we call it V-type compressor. It's required, this V-type is required many additional platform and access area to access the cylinder suction and dampener. This is general arranged for piping study. I don't want you to go more detailed in this one. I don't think it is really important now, unless you are specified in piping mainly. But as a general note for piping, as I told you, this compressor is always a vibrating machine. It has a dampener. So always the piping should have a hold down support, should be supported quickly, adequately. So the pipe that connecting all this pipe that's connected to the compressor, this is second stage compressor, this is first stage compressor, this is a compressor itself, this is a driver. So the pipe that's connecting to the compressor, which going to the knockout drum, this pipe that's carrying the gas itself. So the gas is here in the pipe. So the compressor, which is the part, which is done his part, there is a discharge. So wherever the discharge will go through the pipe. That's why we need a pipe. So this is a pipe for discharge, and there is pipe for suction as well, for intake. So this is why we are using pipe. And this is actually the drum that's part of the compressor while we are using to go inside the compressor. This is the inlet here. If you look to the flow arrow, that gives you indication of the flow direction. So it's come here from the top of the drum, lookout drum. It's only intaking gases. So the gas is coming here. This is the flow direction. Flow direction is like here. Flow direction is going to the compressor. First stage, then go to the second stage, then this is a discharge. This is a discharge here. Then this is the discharge piping. So the discharge piping will go out away. So this pipe actually is containing discharged gases. That means this is compressed gases. This is mean high pressure gases. That means this is what we need. This is actually the product here. Right, the product, it will come from this pipe. So all of this pipe is carrying the gases, either gases with low pressure, which is inlet, or gases with high pressure, which is outlet. So normally we are connecting to a vibrated machine, which is vibrated. So you need to support this pipe adequately. It has to be very good support. So that's why the piping engineers and the stress analysis engineer, they are really working closely in this kind of design to ensure the design is working adequately and the kind of supports and the minimum distance between support is really adequately measured so that there is no any failure or any kind of things will happen to the pipe. This is also another example of the compressor foundation with pipe support that's required to support the pipe, as I told you, to avoid any vibration. Startup strainer is also required in the startup, should be installed in the suction area. Is the same function about the strainer that we used in the pump in the previous lecture, if you remember this one. We use pump, we use strainer. Also, we use strainer in compressor in the suction line to remove any particles to go through the impellers, or sorry, there is no impeller, this is reciprocating. So these particles will go to the piston and cylinder, so we should have a strainer and access for maintenance as required. Okay. So this is also another consideration for piping arrangement and how we operate it from platform and how we are working with piping, with pipe support, all of kind of this arrangement. So I finish, dear brother and sister, and I will give you one more video before we close. So you will clearly know exactly more information about the compressor.
Compressors are used in many different types of compressed gas systems, and a particular facility may have several compressed gas.
This is the V-type. If you remember, I told you V-type like this. This is the one V-type. This is piston and cylinder here. There is inside this one is a piston and cylinder. And there is also another piston and cylinder declination. It is not vertical, it is declined. So they are connecting together like this. They called V-type. V-type. And here, this is, if you look here to this one, this is the knockout drum. That is ensures that is the only flow going to the compressor is gases. So we ensure that the flow only going is gases.
Systems. We can use this simplified illustration to identify the basic components of a typical compressed air system. You may also hear a compressed air system referred to as a pneumatic system. The system includes a reciprocating compressor with 2 cylinders and 2 pistons, an intercooler, an aftercooler, a demister, a safety valve, and a receiver. The compressor is a multi-stage reciprocating compressor. A multi-stage reciprocating compressor contains 2 or more cylinders connected so that the discharge of one cylinder is directed into the inlet of another cylinder. The compressor in this example takes in air at atmospheric pressure and increases its pressure in 2 stages. In the first stage, the compressor increases the pressure of the air to approximately 25 psi. As the air is compressed, its temperature increases. The air that leaves the first stage of the compressor is routed to the intercooler. The intercooler is a shell and tube heat exchanger. As the air passes through the tubes in the intercooler, it is cooled by water flowing around the tubes. The cooled air from the intercooler is routed to the second stage of the compressor. In the second stage of this compressor, the air's pressure is increased to approximately 120 psi. From the second stage, the compressed air is sent to the aftercooler, which is another shell and tube heat exchanger. As the compressed air passes through the tubes in the aftercooler, it is cooled by water flowing around the tubes. During the cooling process, any water vapor that is in the air condenses. As a result, there may be moisture in the compressed air. So, the compressed air is sent from the aftercooler to the demister, which removes moisture from the compressed air. Moisture is removed to prevent it from damaging equipment that uses compressed air. Inside the demister, the compressed air is swirled around inside a cylinder. The swirling action causes the heavier moisture to separate from the lighter air and collect in the bottom of the cylinder. The moisture is then drained from the system. The dry compressed air is routed to other components in the system. The function of the safety valve is to protect the system from excessive pressure. If too much pressure builds up,
So this is actually why we are using this moisture, as he told, is actually to produce a dry gas. We should not have a moisture. Moisture means some droplets, some condensate. Moisture, right, is not 100% dry. It should be dry. So what's the ultimate that we need to reach is we need to reach to a dry gas, dry. There is no kind of condensate, there is no liquid, there is no moisture. So it's ready to be used.
the safety valve will open to relieve the pressure. The receiver is a tank that's used to store dry compressed air. From the receiver, the compressed air is sent through piping to other systems at 120 psi. All of the piping that contains the 120 psi air is referred to as the plant air header or the service air header. The service air header runs throughout the plant to supply air to the equipment that needs it. But pneumatic instruments require compressed air that is extremely clean and dry and at a lower pressure than the air.
So remember now what he said, the instrument device is required air which is extremely clean and dry. Extremely clean and dry. So how you ensure it is dry? You have to use this moisture to remove any kind of condensate, any kind of liquid. It is purely dry. Okay.
Air supplied by the plant air header. Providing this quality of air requires devices such as an oil separator, a desiccant dryer, filters, and a pressure-reducing valve. A small amount of oil is frequently present in the air discharged from a compressor. Since this oil can damage control system components, it must be removed. This function is carried out by an oil separator. The oil that is removed collects in the bottom of the separator and is often drained to a waste system. A desiccant dryer removes moisture that may be present in the air. Filters remove any solid impurities that may be present. Dry filtered air that is suitable for use in a control system is typically stored in a receiver until it is needed. Then it is sent to a pressure-reducing valve. The valve's function is to reduce the 120 psi air to 50 psi for use in pneumatic instruments and devices throughout the plant. The compressed air coming out of the pressure-reducing valve is distributed by an instrument air header. The instrument air header supplies 50 psi air for use in pneumatic control systems. This pressure can be further reduced by the devices that get compressed air from this header. Compressors are used in many.
So we finished so far our lecture today or our session today. Let's open mics and see if you have any questions so far about lecture, or I can ask you also as well. Okay, let's stop recording.